this lesson, we're going to talk about how factoring can be used to solve equations. Before we can solve some equations, though, I'm going to give you something called the zero product rule. This rule basically says anytime you multiply two numbers together and you end up with a zero, you have a product of zero, one of those numbers has to be zero. It's the only way you can get a product of zero. So in the context of solving equations, I have written out the steps that we're going to follow. We're going to start by setting one side to 0. Then we factor so that we have a product. And then we set each factor to 0 and solve. Okay, so let's see what this looks like in an example. In example 1, x squared equals 11x minus 24. The first thing I'm going to do is set the right-hand side equal to 0. I'm going to subtract the 11x and add the 24. Now it doesn't matter which side you set to 0, but factoring is always easiest if the x squared is positive. So now I need to find two numbers that have a product of 24 and a sum of negative 11. Negative 3 and negative 8 work. Finally, step 3 says we set each factor to 0, and now we have two equations that we can solve. The first one, I add 8 to both sides, x equals 8. The second one, I add 3 to both sides, x equals 3. So this quadratic equation, this equation with an x squared in it, ended up having two solutions. Let's go through this same process with example 2. Step 1 is set one side to 0. I'm going to subtract the 17w squared and the 6w to do that. Step 2 is factor. First thing I do in any factoring problem is look for a GCF. This problem has one. Every single term has a w in it. If I factor out the w, I'm left with 3w squared minus 17w minus 6. I have three terms. There's a number in front of the w squared, so I'm going to use that AC method. 3 times negative 6 is negative 18, so I need to find two numbers with a product of negative 18 and a sum of negative 17. Negative 18 and positive 1 will work. So I'm going to use that information to break the middle term up into two terms. Notice I kept the GCF there, the w is still in front. I copy down the first term. I break the middle term up into a negative 18w plus 1w, copy down the negative 6. The first two terms, I can take out a 3w, left with a w minus 6. The second terms don't really have a GCF, but you can always pull out a 1, and you still have the w minus 6. So in factored form, I have w minus 6, 3w plus 1. To finish, I set each of those three factors equal to 0. There will be three solutions here. The first solution is w equals 0. If w minus 6 equals 0, add the 6, w is 6. And for the third solution, if 3w plus 1 equals 0, we can subtract the 1 and then divide by 3, so w is negative 1/3. So this time I had a third degree equation, an equation with an exponent of 3, and I have three solutions. Example 3. We still have to set one side to 0. But in this problem, before we can set one side to 0, we have to get rid of all these parentheses so we can start subtracting things. So I'm going to multiply or FOIL out both sides of this equation. On the left side, first is 5x squared, outer is 1x, inner is 5x, last is 1. And if I combine like terms, I get 5x squared plus 6x plus 1. On the right-hand side, first x squared, outer 3x, inner 2x, last is 6. Combine like terms, x squared plus 5x equals 6. Finally, I'm ready to set one side to 0. I'm going to subtract everything on the right-hand side to bring it over to that left-hand side. 5x squared minus 1x squared is 4x squared. 6x minus 5x is 1x. 1 minus 6 is 5. And now we're ready to factor. There's no GCF. I have three terms, so I'm going to use that AC method. 4 times negative 5 is negative 20. so I need two numbers with a product of negative 20 and a sum of 1. 5 and negative 4 will work. Copy down the first term. I use those two numbers, 5, negative 4, to break up the middle term. Copy down the last term. I can take an x out of the first two terms, left with 4x plus 5. And I'm going to pull a negative 1 out of the second two terms to change those signs. So now I have 4x plus 5 in both parentheses. In factored form, this is 4x plus 5, x minus 1. Finally, I set both of those factors to 0. If 4x plus 5 equals 0, we can subtract the 5 and divide by 4. So x is negative 5/4. If x minus 1 equals 0, I add the 1, x is 1. So I had a quadratic equation here, something with an x squared, and I ended up getting two solutions. Finally, let's take a look at a couple of applications that can be solved using this technique of factoring. In this first problem, I have a right triangle with three sides labeled with variable expressions. To solve this problem, I'm going to have to remember something called the Pythagorean theorem, which basically says anytime you have a right triangle, if you add up the squares of the legs, it always equals the square of the hypotenuse, or that longest side. So if I plug my expressions, x, x plus 1, x plus 2, in for the a, b, and c of the Pythagorean formula, I now have a quadratic equation. So I'm going to try to follow my three steps. Step 1, set one side to 0. But before I can do that, just like in the last example, I have to multiply things out. Now x plus 1 squared is the same thing as x plus 1, x plus 1, so we can use that FOIL acronym to do the multiplication. I have the x squared, which was the a squared part of the equation, and then if I multiply out x plus 1, I get x squared plus x plus x plus 1. If we combine like terms, that becomes 2x squared plus 2x plus 1. On the right-hand side, x plus 2 times x plus 2 is x squared plus 2x plus 2x plus 4. Combine like terms to get x squared plus 4x plus 4. So now I'm going to set one side to 0. I'm going to subtract everything on the right-hand side to move it over to the left-hand side. That gives me 1x squared minus 2x minus 3. Let's see, product of negative 3, sum of negative 2. Negative 3 and positive 1 will work. Finally, I set the factors equal to 0. And if I solve for x, I get x equal 3 or x equal negative 1. Now in this geometry problem, it doesn't make sense to have a negative answer. A triangle can't have a negative height. And so I'm actually going to just cross that answer out because it doesn't make sense. So my solution is x equal 3, and I can actually take that answer and plug it into the other expressions, x plus 1, x plus 2, and find out that the lengths of the sides of this triangle are 3, 4, and 5. All right, one more application problem. This problem says a ball is thrown upward and its height in feet, so h must be height, t seconds after it's thrown is given by the following equation. H equals negative 16t squared plus 48t. Part A, when will the ball be at a height of 32 feet? That's asking us what is the time when, find t, when h is 32. So I'm going to plug 32 in for h into that equation. I have a quadratic equation, so I'll set one side to 0. I'm going to move everything on the right side over to the left. So that means I have to add the 16t squared and subtract the 48t. So now one side equals 0. To factor, the first thing I'm going to do is look for a GCF. There's a GCF of 16. If I pull that out of all three terms, I'm left with a t squared minus 3t plus 2. So let's see, product of 2, sum of negative 3, negative 2 and negative 1 work. So now I set all the factors to 0. But notice this time the GCF is a number, it's 16, and 16 cannot equal 0. That GCF doesn't give us a solution. But t minus 2 could equal 0, or t minus 1 could equal 0. Solving for t, I get t equal 2 and t equal 1. This time I have two solutions, and that's okay. The reason we have two answers is because this ball is going up and then going down, and the t equals 1 must be when it's at 32 feet on its way up. T equal 2 is when it's at 32 feet on its way down. Alright, last problem. When will the ball hit the ground? They're still asking us to find a time, when, but now we want to know when is the height 0. The ground would have a height of 0. So I plug in 0 for h, and now actually I'm ready to factor. One side equals 0. This problem has a GCF. I can pull out a 16 and a t. I think I'm actually going to pull out a negative 16. It's just nice when that first term is positive. So if I factor out a negative 16t, that changes the signs. I'm left with t minus 3. So I set the factors equal to 0. Negative 16t equals 0. We can divide by negative 16 to get t equals 0. T minus 3 equals 0. That means t equals 3. Now the t equals 0 indicates when the ball is starting at the ground. That's the starting time. And so when will it hit the ground implies that you've already thrown it. And so the answer that we're looking for is actually the 3. It'll take it 3 seconds to go up and down and hit the ground.